Find the remainder when 2 power 55555 is divided by 13. So this is nothing but 2 power 55555 divided by 13. Denominator 13 is a prime number. Denominator 13 is a prime number. So you can apply Fermat's theorem. 2 power 12. 12 fours are 48. 75, 12 6 are 72, 35, 35, 12 2s are 24 into 2 power 11 divided by 13. These anyway 1. So this will become 2 power 11. 2 power 11 divided by 13. Already in the morning we discussed, in the second class we discussed the Fermat's theorem. You can apply the same format or you can divide it. 2 power 11 will become 2048 divided by 13. 13 ones are 13, 74, 13 fives are 65, 98, 13 sevens are 91. Remainder is 7. Remainder is 7. I hope the idea is clear. This one is nothing but 1. When the denominator is a prime number, you can use Fermat's theorem. I hope the idea is clear. 43rd question. I hope the idea is clear. 44th. Find the remainder when 3 power 555 is divided by 7. 3 power 555 is divided by 7. When it is 7, it is 3 power 6. 6 9s are 54. 15 into 3 power 3 divided by 7. This is nothing but 1. 27 divided by 7. 7 4s are 28 minus 1. Negative remainder minus 1. Positive remainder will be 6. Positive remainder will be 6. You can also use backtracking in the previous question. You are right, Riyas. You can also use backtracking. I hope the idea is clear. 44th. Next, 45th. Find the remainder when 777 is written 100 times is divided by 13. Now, please put a star mark on this point. Star mark on this point. Note. Remainder when 10 power 6 divided by 13. Let us see what is happening. Or 10 power 3 we will take. Remainder 1. 10 power 3 divided by 13. 13 ones are 13 minus 3. Minus 3 cube is minus 27. 13 twos are 26 minus 1. 10 power 3 divided by 13 is minus 1. Suppose if the question is remainder 1. 1 2 3 1 2 3 divided by 13. This is nothing but remainder 1. 123 into 10 power 3 plus 123 divided by 13. 10 power 3 divided by 13 is minus 1. Minus 123 plus 123 is 0. Minus 123 plus 123 is 0. Extremely important point. Any three-digit number written even number of times. Any three-digit number written even number of times is always divisible by 13. It is also divisible by 791,001, but we'll discuss it later because the context is 13. Please write down. any 3-digit number written even number of times is always divisible by 13. Why it is divisible by 13? Because 10 power 3 divided by 13 is minus 27 divided by 23 is minus 1. If it is 10 power 3, I am getting minus 1. So 123 divided by 13 will be 123 into 10 cube plus 123 divided by 13. 10 cube divided by 13 will be minus 1. Minus 123 plus 123 will be 0. Any 3-digit number written even number of times is always divisible by 13. Any 3-digit number written even number of times is always divisible by 13. I hope it is clear, right? So based upon this question is 777. If 777 is a 3-digit number, if it is written 2 times, what will be the answer? 0. That means if 7 is written 6 times, what is the answer we are getting? 0. If 7 is written 12 times, here also it is 0 because 777 is written 4 times. So till 96 times, the answer will be 0. What will be left? Only 4 7s are left. Divided by 13. This also can be written as 7 into 10 cube plus 777 divided by 13. 10 cube divided by 13 is minus 1. So it is nothing but 770 divided by 13. 13 5s are 65. 120. 13 8s are 104. 16. 13 9s are 117. Answer is 3. I hope the idea is clear. Any 3-digit number written even number of times is always divisible by 13. Any 3-digit number written even number of times is always divisible by 13. Any single non-zero digit written in groups of 6 is always divisible by 13. Any single non-zero digit written in groups of 6. It is nothing but a 3-digit number written. Right, even number of times. I hope the idea is clear. Very good question. Very good question. Any 3-digit number written even number of times divided by 13 is 0, or any single non-zero digit written in groups of 6 is also 0. So 100 means 6 16s are 96, remaining 4 7s. Either you can do 4 7 divided by 13 or use the concept of 7 into 10 cube by 13. Next, same thing we can also use it for concept. Two concepts I will discuss. First, 2 cube divided by 10 cube divided by 11. 11 ones are 11 minus 1 cube, so it is minus 1. Same concept. Any 3-digit number written even number of times is always divisible by 11. In fact, not 11, it is also 7, 13, 91 and 1001. 11, this is one way. So if it is 1 means 2 is written 6 times. 0 remainder. 6 times it is 0. So how many times it will go? 12 times it is 0. 198 times it is 0. So remaining 3 2s are left. 2 2 2 divided by 11. 2 plus 2 4. 4 minus 2. 2 2 2. 11 20s are. Answer is 2. Answer is 2. I hope it is clear. Idea is clear. This concept 1. Method 1. Any 3-digit number written even number of times, it is always any 3-digit number written even number of times. Written even number of times is always divisible by 11, is always divisible by 11, is always divisible by 11. So 6 times, 12 times, 18 times, 24 times, 198 times. Remaining is 36. 222 divided by 11. 11 20s are 220. Remaining is 2. I hope the idea is clear. This is method 1. Method 2. Method 2. If 2 is written 4 times, what is the divisibility rule of 11? Another divisibility rule. Divisibility rule for 11. Sum of odd places minus sum of even places minus sum of even places, sum of even places should be either be divisible by 11 or 0. Am I right? Divisibility rule of 11. So 2 plus 2 4, 2 plus 2 4. Remainder is 0. 0. If I write 8 times 8, here also it is 8. It is 0. So if it is divisible by 11, if it is divisible by 11, groups of 4, it is 0. 450s are 200. Remaining answer is 2. Remaining answer is 2. I hope the idea is clear. Sum of the odd places minus sum of the even places, answer should be either 0 or 11. If I take a group of 4s, 2 plus 2 4, 2 plus 2 4, 4 minus 4 0, again 8 0. So any groups of 4 is always giving me remainder 0. 450s are 200. So answer is 2. Either ways you can do 10 cube divided by 11 you can do, or you can use this divisibility rule of 11, sum of the odd places minus sum of the even places.
Press the bell icon on the YouTube app and never miss another update.
Now find the remainder when 191919 is written 8 times is divided by 7. So what is the concept? Remainder of 10 cube divided by 7. 7 ones are 7, 3 cube 27. 27 divided by 7. 7 fours are 28 minus 1. 10 cube divided by 7 is minus 1. 191919. Total how many times? 8 times. 1 2 3 4 5 6 7 8 9. 7 8 9. So 10 cubed, this entire number when divided by 7, what is the remainder? Take a group of 3 digits. Take a group of 3 digits. Take a group of 3 digits. Alternatively plus minus. Alternatively plus minus. Alternatively plus minus. So if you observe, what will be what is this? This is 919. This is minus 191. Again 919. Again minus 191. Here it is 999 how many times? 1 time, twice, thrice. So instead of this you can directly write like this. Instead of this directly you can write it as 919 is added how many times? 3 times. 3 into 919. 191 is subtracted how many times? 2 times. 2 into 191 plus 1 divided by 7. Final value came up to like this. I hope it is clear. Why we got plus minus plus minus? If anybody got a doubt, you can do like this. 191 919 divided by 7. This is nothing but 191 into 10 cube plus 919 divided by 7. 10 cube by 7 is minus 1. Now you can do, right? 7 13s are 91, 7 1s are 7, 2 remainder. So first one is 6 minus 7 1s are 7 2s are 14, 51, 7 7s are 49, 2 minus 4 plus 1, minus 4 plus 1. So you can into 3 we got, into 3. So these is nothing but calculate it and get the answer. I hope the idea is clear. 10 cube divided by 7, 7 ones are 7, remainder 3, 3 cube divided by 7 is 27 by 7 minus 1. Apply the same concept, do the calculation, you will get the answer. Do the calculation, you will get the answer. Do the calculation, you will get the answer. Idea clear? Right, 47th, 48th. What is 48th? Remainder 1, 2, 2, 2, 2 is divided by 7. So we have already done it in the morning class. 4 2's power 4 5's plus 4 5's power 4 2's divided by 7. Now see here. So take a group of 3 digits alternatively plus minus. 222 minus 2 is 220. 220 divided by 7. 7 3's are 21, 10. 7 1's are 7, 3. So these are nothing but 3 power 5, 5, 5, 5, 5. 555 plus minus 555 minus 5 is 550. 550 divided by 7. 7 7s are 49, 60. 7 8s are 56, 4. Already we did it. 4 power 2, 2, 2, 2, 2 divided by 7. So if it is 7, you can also do like this. 3 power 6 power. 6 9s are 54, 15. 6 2s are 12. 6 9s are 54, 15, 6 2s are 12, 35. 6 5s are 30. Remaining is 3 power 5 plus 4 power 6 power. 6 3s are 18, 42, 6 7s are 40 into 4 square divided by 7. These one and these one. 243. 243 plus 16 is 259. 259 when divisible by 259 when divisible by 7 is nothing but answer 0. I hope it is clear. Idea is clear, right? Already we did it in the first class. A power n plus b power n is always divisible by a plus b if n is odd. A power n plus b power n is always divisible by a plus b if n is odd. 48th clear, right? Idea clear? 48th. 49th. 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 I'm sure you can solve this question if I reminder 1. 32 power 32 power 32 divided by 5. 5 6 are 30. Remaining is 2 power 32 power 32 divided by 5. Divided by 5. Now if you see 2 power, which power of 2 when divided by 5? I'll get 1. 2 power 5 when divided by 5. 16 when divided by 5, it is 1. So divide this with this. So if I divide 32 power 32 when divided by 4, 32 is divisible by 4. So remainder 0. 32 power 32 is nothing but 4k. 4k. So these is nothing but the remainder of 2 power 4k when divided by 5. So which will become remainder of 2 power 4 power k when divided by 5. 16 when divided by 5. 1. Idea clear, right? Already we did a lot of problems in the morning with respect to negative remainder. 32 power 32 power 32 divided by 5. 5 6 are 30. 2 power 32 power 32 divided by 5. 2 power 4 when divided by 5 is 1. 32 power 32 when divided by 4. 32 is divisible by 4. So remainder 0. So 2 power 4k when divided by 5. 2 power 4k is 2 power 4 power k divided by 5. 16 divided by 5 is 1. Answer is 1. Idea clear, right? 49th. Idea clear, 49th. It's an easy question if you know the concept. Find the remainder 1. 2 power 51 is divided by 5. 2 power 51 divided by 5. Denominator 5. 5 is a prime number. So numerator it will be a power p minus 1. 2 power 4 power 12 into 2 power 3 divided by 5. This is 1. 8 by 5. 5 ones are 5. Remainder will be 3. Remainder will be 3. Idea clear, right? So if the denominator is a prime number, use Fermat's theorem. If the denominator is a composite number, use Euler's theorem. If the denominator is a prime or composite, use a negative remainder. I will give a table after the third class which concept to be used when. Which concept to be used when. Next one. Some more examination question. Find the remainder 1. 2 power 140 is divided by 17. 17 means numerator has to be 16. So if I take 16 ones are 16, 54. 16 threes are 48, 60. 16 threes are 48. 12. 3 power 12 divided by 17. So these is nothing but 1. 3 power 12 when divided by 17. 3 power 12 when divided by 17. You can use Fermat's backtracking method also. 3 power 16 when divided by 17. It is 1. So these is nothing but 3 into 3 power 4 into 3 power 12 divided by 17. It is 1. 81 divided by 6. 17. 17 fours are 68. 13. So 13x when divided by 17. It is nothing but 1. 13x is 17k plus 1. 13x is 13k plus 4k plus 1. Divisible by 13, divisible by 13. So 4k plus 1 is divisible by 13. So k value is 3. If k is 3, 13x is nothing but 17 3s are 51 plus 1, 52. X is nothing but 4. Good question it is. Good question it is. 3 power 2140 divided by 17. 3 power 2140 divided by 17. If the denominator is a prime number, numerator it will be 3 power 16 power 133 into 3 power 12. 3 power 16 by 17 is 1. 3 power 12 by 17. Use the backtracking method which I taught you. 3 power 16 by 17 is 1. 3 power 4 into 3 power 12 by 17. 3 power 4 by 17. 81 by 17. 17 fours are 68. 13. 3 power 12 by 17 I require. So 13x divided by 17 is 1. 13x is 17k plus 1. 13x is 13k plus 4k plus 1. 13x is divisible by 13. 13k is divisible by 13. 4k plus 1 should be divisible by 13. K value is 3. 13x is 52. X value will be 4. X value will be 4. I hope the idea is clear. Next two problems are on backtracking. I think both are not. I think backtracking some more questions I will develop after this. 52 power 50 divided by 31 directly. 31 is a prime number. So upper it has to be p minus 1. So answer is nothing but 1. How it is directly? A power p minus 1 divided by p is 1. When the p is a prime number. When p is a prime number. When p is a prime number. Similarly, if it is 29, this will be 28 power 2 into 17 divided by 29. This one. Answer is 17. Answer is 17. Idea clear, right? 17. Idea clear, right? 52 and 53. Next one. 50 power 51 power 52 divided by 11. So this will become 50 power 10 by 11, which is nothing but 1. 51 power 52 divided by 10. 51 power 52 divided by 10. 10 5s are 50. Remainder 1. 51 power 52 is 10k plus 1. So this will become remainder of 50 power 10k plus 1 divided by 11, which is 50 by 11. 11 4s are 44. Remainder is 6. Remainder is 6. Idea clear, right? Power to power also you can do it. Power to power also you can do it. 55 problems only based on reminders. Only based on reminders. 2 power 2005 divided by 13. 2 power 12 power 12 ones are 12, 80, 12 6 are 72, 85, 7 into 2 power 1 divided by 13. This over. 2 divided by 13 is 2. 2 divided by 13 is 2. Idea clear, right? Two divided by 13 is 2. Idea clear? 54 and 55, 56. If a 6-digit number is formed by a 3-digit number written, repeating a 3-digit number, already what we wrote it? Remainder 1, 10 cube divided by 7, 11, 13 are 77, 91, 143, 1001. B is nothing but minus 1. Already we wrote any 3-digit number. Any 3-digit number written even number of times. Written even number of times. Even number of times is always divisible by. Is always divisible by. Is always divisible by 7, 11, 13 multiples 77, 91, 143, 1001. So answer is 1001. 1001. Why? Looking at the question itself, you can say 1001 is 7 into 11 into 13. If this is right, all the three will also be right. All the three will also be right. Any 3-digit number written even number of times. Any 3-digit number written even number of times is always divisible by 7, 11, 13 and its multiples. Any 3-digit number written even number of times is always divisible by 7, 11, 13 and its multiples. 56. If a 6-digit number is formed by repeating a 2-digit number 3 times, 2-digit number 3 times, 141414 14. What is the sum of the digits? 555. 15. 15 is divisible by 3. Answer should be divisible by 3. Answer should be divisible by 3. What is there in this question? Answer is 10101. You write any 2-digit number, any 2-digit, right? Any 2-digit number, write down 3 times. 2 plus 2, 4, 4, 4, 4. 4 plus 4 plus 4, 12. 12 is divisible by 3. 12 is divisible by 3. right? Any two-digit number written in 3 times is always divisible by 3. What is the divisibility rule of 3? Sum of the digits should be divisible by 3. A, B and C out.
Press the bell icon on the YouTube app and never miss another update.
If a 4-digit number is formed, by repeating a 2-digit number 2 times, concept. See here. Reminder 1. 10 square divided by 101. 100 divided by 101 minus 1. Suppose if the question is 25 divided by 101. This can be written as 25 into 10 square plus 25 divided by 101. This is minus 1. Minus 25 plus 25 is 0. Always remember, any two-digit number written even number of times, is always divisible by 101. Any two-digit number written even number of times, is always divisible by 101. Any two-digit number written even number of times. Any three-digit number written even number of times is always divisible by 1001. 59th question. Find the remainder 1. 10 power 10. 10 power 10 divided by 7. Denominator 7. Numerator it will be 10 power 6 into 10 power 4 by 7. This is 1. 10 divided by 7. 7 ones are 7. 3. 3 power 4, 81. 7 11s are 77. Remainder 4. Similarly, 10 power 100 divided by 7. Power should be 6. 6 16s are 96. Remaining 10 power 4 by 7. This is also 1. 10 power 4 by 7 is 4. Every time I am getting 4. So 104, 2 zeros 4. 102 total how many zeros? 3, 6, 9, 10. 4 is added 10 times. 40. Am I right? 1020 total 3, 6, 9, 10. So 40. So 40 divided by 7. 7 5s are 35, 5. Answer is 5. Remove one option. Answer is 5. I hope the idea is clear. If the denominator is 7, power will be 6. So 10 power 6 into 10 power 4 by 7. 10 power 4 is 80. 7 ones are 7. 3 power 4. 81 divided by 7 is 7 11s are 77. 4 is coming from 10 to 10 zeros. So total 4 is added 10 times. So 40 divided by 7 is 7 5s are 35. Answer 5. Next one. Now this is nothing but backtracking. Reminder 1. 53 power 17 divided by 19. 19 2s are 38. It is 15 power 17 divided by 19. According to Fermat's theorem, 15 power 18 divided by 19 is 1. So 18 is nothing but 15 into 15 power 17 divided by 19 is 1. 15 divided by 19 is 15. 15 power 17 by 19, it is x. When I further divide, remainder does not change. 15x is nothing but 19k plus 1. 15x is 15k plus 4k plus 1. Divisible by 15, divisible by 15. This has to be divisible by 15. 4k plus 1 is 15. K has to be an integer. Not possible. 30. Not possible. 45. Yes, possible. K will be 11. K will be 11. If K is 11, substitute it. 15x is 19 into 11 plus 1. So it is 15x is 210. X will be 14. X will be 14. Idea clear, right? X will be 14. Backtracking for Fermat's theorem. Backtracking for Fermat's theorem. Total 60 questions we discussed only in reminders. Still some more questions are left. Still some more questions are left. 7 power 20 divided by 22. 22. 22 is a composite. Okay, what you do is you change the question, sir. It is. We are discussing when the denominator is a prime number. So you change it to 7 power 17 divided by 19. 7 power 17 divided by 19. 19 means power should be how much? 18. 7 power 18 divided by 19 is 1. 18 is nothing but 7 into 7 power 17 divided by 19 is 1. 7 divided by 19 is 7. This is nothing but x. When divided by 19 is 1. So 7x is nothing but 19k plus 1. So 7x is 14k plus 5k plus 1. Divisible by 7, divisible by 7. 5k plus 1 should be divisible by 7. K should be an integer. K will be fraction if I take 7. K will be fraction 21. K value is 4. If K is 4, 7x is 77. X value is 11. X value is 11. I hope the idea is clear. I erased that question because we are discussing Fermat's theorem. Fermat's theorem works when the denominator is a prime number. Denominator is a prime number. Idea clear, right? Idea clear? All the varieties of Fermat's theorem which we discussed. Now, these are some high quality questions. Next are high quality questions. Next are high quality questions. There are a lot of questions are there. Chinese remainder theorem is also there. Denominator. That will be the last session of our class before we move on to the next question. Right? These are the topics which we discussed. Thank you. I think 14 students have purchased it after the first class.
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our revolutionary app for free. AMC.